So before moving to the next topic, let's see our roadmap again. We have completed the collection interface, the list interface, the implementation class of list interface, that is array list. We have completed linked list, vector, stack. These are the implementation classes of list interface. Then we have seen set interface. What is the difference between list interface and set interface? Hash set, that is the implementation class of set interface. Linked hash set, that is the implementation class of set interface and a child class of hash set. Then we have seen sorted set, navigable set. These two are the implementation. These two are interfaces of set, the child interfaces of set, and tree set is nothing but the implementation class of navigable set and the sorted set. Fine. There are many new methods in list which are not in collection, but there are no new method in set which are not in collection. Okay, we have seen this. Now we will begin with queue. Okay, we will see what is queue. What is priority queue? Priority queue is an implementation class of queue. Fine. So let's move on to queue. Queue interface. So in queue interface, it is a child interface of collection. We have all seen it. Then if we want to represent a group of individual objects prior to processing, then we should use queue. I have already told you about this. So let's take another example. Now this is a queue. Okay, we have a front and a row, front and a rear inside a queue. So a queue is used if you have learned operating system. Now in operating system, we have all learned a concept of priority queue, correct? That is, in process scheduling, we learn about priority queue. So in priority queue, the process with the highest priority is at the front and the process with the least priority is at the rear. Why? Because from the queue, from the front, there is deletion. Okay. And from the rear, we have our insertion. From the rear, we insert, and from front, we delete. Okay. So because deletion is from the front, the priority processes, which are higher priority processes, are in the front. They are deleted first. So queue follows first in, first out. Queue follows by default first in, first out. Fine. If I have 5 processes, P1, P2, P3, P4, P5, correct? And in these 5 processes, let's suppose the numbers are the priority. 1 has the highest priority and 5 has the lowest priority. And P1 is inserted. So first P1 will be inserted here, correct? This is the rear and this is also the front. Then the rear will increase, so the rear will point here now. If P2 is inserted, P2 will be inserted in this point. Then the rear will be again increased, the P3 will be inserted here, rear will increase again, P4 will be inserted here, and P5 will be inserted here. During deletion, the front deletion will happen from the front. So when P1 is deleted, front will now move to P2. Now when P2 is deleted, front will move to P3, then P4, and then P5. So the highest priority process, that was P1, is executed first because it was deleted first from the queue. So this is just an example of queue. You can also take the mailing example that I have told you when last time we were discussing about queue. So if you want to send mail to suppose 10 of your friends, okay, then you have to maintain a queue that is M1, M2, M3, M4 to M10. That is a mailing list. Okay, then in this mailing list, one by one, the mail will be sent. The first mail will be sent to M1, then the mail will be sent to M2, then to M3. Fine. Here also, prior to processing, these programs are not currently processing. They are in the queue. Once it is deleted from the queue, then they go to the CPU for processing, correct? So prior to processing, when we want to store some elements, some programs, then in that case, we use queue, correct? So in this case also, we will using queue. So these were some examples of queue. Next point is priority queue implementation is used to have FIFO order, or we can have our own customized order. So in priority queue always has a FIFO order. Okay, not always. Queue in itself has a FIFO order. By default, it is first in, first out order. But using priority queue, we can also have our own customized order. For example, this was FIFO order. That is, first one was P1, so it has the highest priority. Then P2 was the first one, that it has the second highest priority. Correct? And if we want to have our own priority order, we can have that P5 has the highest priority. We can do that. Okay. Now for customized order, we all know, we have seen just before this topic that comparator is used. For customized ordering, comparator is used. So, and we also have a linked list based implementation of queue. This linked list based implementation of queue is introduced after 1.5 version. At 1.5 version, this linked list based implementation of queue is after 1.5 version. So this linked list based implementation of queue was given, and it always follow FIFO order. So using priority queue, we can have our own ordering as well, and by default it is FIFO, but we can also have our own customized ordering. Next point is, let's see the methods in queue interface. So first one is boolean add. Okay, so what does boolean add does? It is simple. It adds the element inside the queue, okay, without violating the capacity restrictions. Okay, so if my queue is of size 10 for example, so without violating these capacity restrictions, what will happen? The add will add these elements. Okay, now in case of 11th element, if there are two types of queue, we can have bounded queue or we can have growable queues, correct? So if we are using a bounded queue, then on the 11th insertion, insertion, it will simply throw illegal state exception if there is no space currently available. Offer, what it does, same thing, it also adds. What offer does is also add. The first point is same, inserts the specified element into the queue if it is possible to do so. Okay, what is the change is it does not throw an exception but it returns a false value. Okay, it does not throw an exception but it returns a false value if the queue is full. Next is remove. So it is remove, so it just removes the element of the queue and the queue is empty. We have no such element exception. Poll also removes it, but we do not have a no such element exception, or no type of exception is thrown, but it will return a null if the queue is empty. Next we have element, so it will retrieve an element but not remove it. If we see here, it retrieves and removes. So both remove and poll retrieves and removes the head of this queue. They retrieve and remove the head of this queue, correct? But element retrieves but not remove the head of the queue. Okay, they both retrieve and remove, but element does not remove the head of this queue. And peek also does the same thing, only change between element and peek is element throws no such element exception but peek returns null. Okay, so these were the methods in queue interface. These methods are implemented by priority queue. Okay, so we will see in coding example using priority queue, and we will see these all methods in action. Fine, so the next topic now that we will see is priority queue class. So this is an implementation class of queue interface. This is an implementation class of queue interface. So a priority queue is used when the objects are supposed to be processed based on their priority, correct? If we have a higher priority, then that object should be processed first, then a lower priority process, correct? Then priority can be either default natural sorting order or customized sorting order, correct? So if we have a default natural sorting order, then for numbers, ascending order is a priority. Okay, so 1 has a higher priority than 2, 2 has a higher priority than 3. Fine. Also for strings, A has a higher priority than B has a higher priority than C. The alphabetical order will be followed. But we can also have customized sorting order. Fine. Then insertion order is not preserved. Duplicates objects are not allowed. For default natural sorting order, only homogeneous and comparable. So we have seen this same point in the previous topic also. Okay, we have seen the same point in previous topic. So for default natural sorting order, homogeneous plus comparable, but for customized sorting order, we can have homogeneous as well as heterogeneous plus comparator. So what we do with the help of comparator, it's very simple. With the help of comparator, we can give our customized sorting order. Okay, so in this case, customized priority order. Fine, or default natural priority order, no issue. Now let's see the constructors of priority class. So the constructors in priority queue class are priority queue. This is the simplest, this is the default constructor that will create an empty priority queue, but with the initial capacity of 11, okay, that orders its element according to the natural ordering. So what is natural ordering? It is very simple, I have already told you. For numbers it is ascending, for string, for characters it is alphabet. Now priority queue with initial capacity, if the initial capacity we know what is the initial capacity, then we can provide the initial capacity, and the ordering is still natural ordering. Then initial capacity plus comparator. Now we have given the initial capacity, but ordering is not natural, it is customized. Okay, priority queue, if we want to convert a priority queue into another priority queue, we can use this. If you want to convert a sorted set into a priority queue, we can use this constructor, and if you want to convert a collection into a priority queue, then you can use this constructor. Okay, so we will see the first one in our code now. So now let's write our code. Okay, now here we will go slowly. Now in the coding process we will go a little bit slow than the explaining process. Okay, here also I will explain those points again. So string priority queue equals to new priority queue. Fine, so this I have created a priority queue. Now I have used a default constructor, so the natural sorting order will be used and the initial capacity will be 11. Fine, now let me add some values. Priority queue dot add. I hope you guys watch some TV series. Okay, so this is my priority, you can have your own priority. So Breaking Bad, first one. Then priority queue we can have got dot add got. Okay, got stands for Game of Thrones, but you guys should know it. Okay, so priority queue dot add. Next one I can have friends. Let's see the next one. Priority queue dot add. Similar to friends, we can have How I Met Your Mother. How I Met Your Mother. Okay, and the next one, what should I add at the end? So let's have supernaturals. Fine. So this is my queue. This is my queue. Now since I am using a default constructor, and let me print it also, since I am using a default constructor, so it will be natural ordering. The priority will be natural ordering. Fine. Now if I add if I just run it, the queue will have Breaking Bad, got, Friends, How I Met Your Mother, and supernaturals. Fine, this is there. But what are the priorities? What are the priorities? This is not according to priority. Okay, what are the priorities? Priorities are, the first is B. So B has the first priority, that Breaking Bad has the first priority. Then before G, F comes. So F has the second priority. The Friends have the second priority. Then got has the third priority, HIM has the fourth priority, and supernatural has the last priority. Okay, I will show you how this happens. Let's print the head. Let's print the head. So S out, very simple, head equals to, and we will use peek method. We will use peek method for head. So what peek method does, it retrieves the head, but it does not delete it. What peek method does, it retrieves the head, but it does not delete it. Okay, so let's just run the program and see the output. So the head is now Breaking Bad. So the first priority, I have shown you, the head is now Breaking Bad. So head of the queue is Breaking Bad, means the first priority, head points to the highest priority. So the first priority is given to the Breaking Bad because of B, because of natural sorting order. Okay, now if I show you the next one, so I will show you the next one, head after delete. So I will use now poll. I will use now poll. So when I use poll function, what poll function does is it retrieves the head and it deletes it. It retrieves the head and it deletes it. So I will just print my priority queue. So I will just print my priority queue to show you that Breaking Bad is now deleted, and the next priority string will come first. As you can see, poll function also retrieves the head, but it deletes it, and the next priority is given to friends. Why? Now head becomes friends. Okay, so head is now pointing to friend. So why friend? Because F comes before G, S or H. Correct? And you can see the insertion order is never maintained. Okay, so F becomes first. So we have the head now. Now what we can do after this, you can use an iterator to iterate this. Okay, we haven't used iterator in a long time. So iterator, itr equals to priority queue dot iterator. Okay, then what we can do, while itr dot has next, simple, and I will just print the whole queue, s out itr dot next. Okay, so this will print the whole queue for me. So I will have friends first, then got, then supernatural, then How I Met Your Mother. So friends is currently the head. Friends is currently the head. Okay, let's now delete friends. Okay, or if you want, I can just use the peek method to show you that friends is currently the head. So head equals to, again, and I will use peek. So what peek does, it only retrieve the head, does not delete it. So it will not delete friends, it will only retrieve it. So as you can see now here, that the output here comes head equals to friends. So the head is now friends. Okay, so the next priority after friend will go to got, because G comes before S and H. Let's see it. So I will just remove the head one. So I can use again the poll method. Okay, priority queue dot poll. So what poll method will do, will simply delete the head. Okay, it retrieves and deletes the head. So my head is now deleted. Now let me see, after my head is deleted, that is the friend is deleted, who becomes the new head. Let me print the new head. Okay, so the new head becomes, as you guys would know till now, if you use peek, you will get the head. So let's see. So the new head now becomes after friends, F comes G. So the new head will become got. Okay, so these were some functions, some methods. We can use different methods also. Let's use contain. So system.out.println is got in my queue. Okay, is got in my queue? Yes, it is in my queue, so it should return me true. So which method we will use? We will use contain method. So remember, everything is a child of collection till now, correct? So collection methods are used by every implementation class. So also priority queue can use contains. So because contains is a method of collection class, so we can use it and pass GOT in it. And now the answer should be true because GOT is present inside my queue. Okay, if now because I have used poll and friends is now deleted, okay, I can show you sort.print priority queue, and now in the priority queue, because head is GOT, now friends is deleted. Now if I use contain methods for friend, I will get simply a false answer. Okay, you can do that. We can also use remove method to remove something. So priority queue dot remove, and I can remove how I met your mother. Okay, I can remove how I met your mother. If I print now the list, it will be simply without how I met your mother. So after GOT, how I met your mother should have gotten the priority, but I have removed how I met your mother. So the priority now will go to supernatural. That is the only one remaining. If I delete now GOT, the priority will go to supernaturals. So this was priority queue. This was the queue concept. With the queue concept, we have completed our collection interface. It was a long journey. We have seen so many things in collection interface. It does make our work easy. Collection interface does make our work very easy, but it has a drawback too. The drawback is performance. Okay, because there are so many inbuilt methods we are using, so there are many function calls, fine, so the performance is hindered. But yes, for the programmers it is very good. The collection framework for the programmers is very good. Okay, so this was collection interface. Now next we will see the map interface. After collection interface we will see map interface and the child classes of map interface and the implementation class of the map interface. Okay, thank you.